When climbing, the fall factor is a measure of the severity of a fall, and in consequence, the degree of risk it poses, and the consequences for the entire climbing party. This theoretical value falls in the range 0 to 2 in climbing conditions. The fall factor is calculated by dividing the height of the fall by the length of rope in play. Here are two examples. In this first case, the belayer is at point A. The runner is situated 2.5 meters above him, that's at point B. The climber continues up his route and reaches point C, situated 2.5 meters above the runner. The climber falls. The length of his fall is 2.5 plus 2.5, or a total of 5 meters. The length of rope used is 2.5 plus 2.5, a total of 5 meters. The fall factor will be 5 meter length of fall divided by 5 meters of rope employed during the fall, or a factor of 1. This is a reasonable fall factor. In this second case, the belayer is still at point A. But this time the runner, point B, is located at the level of the belayer. The climber progresses up the route to point C, situated 2.5 meters above the anchor point and the belayer. The climber falls. His length of fall is again 5 meters. But this time the length of rope in use is only 2.5 meters. The fall factor becomes 5 meters divided by 2.5 meters, thus 2. In this case, the fall factor is 2, a critical factor for the climber. For a given length of fall, there can be two completely different fall factors. There can be a comfortable fall factor of 0.8 with a length of fall of 20 meters. And a very dangerous fall factor of 2 with a length of fall of only 1 meter. The second fundamental concept after the fall factor is the impact force. The impact force is the force transmitted to the climber, to the carabiner, and to the belayer at the moment of arrest of a fall. A severe impact force may have dramatic repercussions for the entire rope chain, on the climber and the belayer, who must withstand the shock, but above all, it is the running belay which may give way. High quality rope can lower the impact force by absorbing the energy of the fall. Don't forget, minimum impact force means maximum security. It is therefore essential to choose the right rope. Climbing rope, single rope and double rope must meet specific standards. Every rope sold on the market is tested in order to check its characteristics in relation to this standard. For a single rope, the test is made at factor 2 with a mass of 80 kilograms. The impact force holding the first fall must be below 1,200 decanewtons. The rope must withstand a minimum of 5 falls, spaced at 5-minute intervals. For double rope, the test is made at factor 2 with a mass of 55 kilograms on a single strand. The impact force must remain below 800 decanewtons. The rope must again withstand a minimum of 5 falls made at 5-minute intervals. A high-quality rope will have a characteristic lower than that of the standard after the 7th, 8th or even 9th fall. The key requirement when choosing a rope is that it retains its characteristics over a long period of time. This is ensured by high-quality manufacturing. When buying a rope, it is important to bear in mind that not all ropes meet this important requirement. It is not only the climber and belayer that are affected by a fall. The anchor points are also put to the test. During a fall, they are subject to a double combined action, that of the falling climber and that of the belayer. This is called the pulley effect. A pulley effect can cause the anchor point to rupture. A high-quality rope will minimize the force on the anchor point by absorbing the energy of the fall. Here again, the rope can contribute to the safety of the whole rope party. Bear this in mind when choosing a rope. When using random anchor points, certain rules are applied to keep risks to a minimum. On ice climbs protected by ice screws, climb on double ropes with inline belays but clipped alternately. On long routes or when mountaineering with pitons, use double rope, clipping each strand alternately. For other adventure climbing, protected by friends or nuts in a crack, again use double rope but clip alternately. This way of climbing firstly minimizes the drag as the leader climbs, because the rope runs more directly. Secondly, in the case of a fall, all the length of the rope can work to absorb the energy, and so the impact force will be less, and the fall factor will be reduced, which is crucial for the entire rope system. The three fundamental concepts in climbing are therefore the fall factor, the impact force, the pulley effect. It's the rope, because of its characteristics, which supports the comfort and security of the climber, and peace of mind for the belayer, and does it for the whole lifetime of the rope. For this reason, the choice of rope is decisive. It must be made in full knowledge of how it must work.